Solving inequalities. This video contains two examples. Solve the inequality that 5x minus 3 is greater than or equal to 12 and x is a real number, and then we're to graph the solution. We're going to solve this largely treating it like you would an equation. So the left hand side is larger than the right hand side, but if we add 3 to both sides, this will still be the case. Adding 3 to both sides will simplify the left hand side, leaving us with 5x being greater than or equal to 12 and 3 is 15. I'm more interested in x than 5x. If we divide both sides by 5, the left hand side would still be greater than the right hand side. So dividing by 5, we see that x would be greater than or equal to 3. Now we want to graph this solution on a number line. So x is greater than 3. I suppose you must also recognize that it's not every number greater than or equal to 3. X is only natural numbers. Natural numbers are counting numbers, whole positive numbers. So we want to graph this on a number line. So I'm interested in number 3 in particular, and numbers greater than 3. I definitely want to show this. So you might set up a number line. And because it's natural numbers, these are discrete values, or it's going to be a set of dots or points along the number line, as opposed to a filled in number line if it was real numbers. So it includes 3 because it's or equal to 3, and numbers greater than 3, 4, 5. Now we can't go on forever, so we'll just draw an arrow at the end that symbolizes it goes on following this pattern forever. Solve the inequality that 4 minus 3x is greater than negative 5, and x is an element of z, which means it's an integer. Okay, in this problem we have a negative x on the left hand side, which makes it more complex. But let's start off by taking 4 from both sides. This is a fair thing to do. The left hand side will still be greater than the right hand side, and we're left with negative 3x is greater than negative 5 take 4, which will be negative 9. Now the next step is the important step. I'd like to multiply everything by negative 1. In other words, change all the signs. When I do, I also must change the direction of the inequality. That's the key step in this. So 3x is smaller than 9. I can divide both sides by 3. Then the left hand side is still smaller than the right hand side, giving us x is smaller than 3. And x is an integer. So it's not every number smaller than 3, just whole numbers smaller than 3. And now I'm going to graph this on a number line. I'm just interested in numbers smaller than 3, and because it doesn't include 3, maybe it's okay to start at 3. I could start at 4 either. But the first number smaller than 3, not equal to it, is 2. So I have 2, 1, 0, negative 1. Just the whole numbers. Again, because this pattern, I can't go on forever, I draw an arrow at the end to say it continues.